All right, we're still looking at exponential functions, and we're going to start with example 3. If you want to see the first couple examples, go back to the previous video. All right, example 3, graph each function. Compare the graph to the graph of the parent function. Identify the y-intercepts and the asymptotes of the graph. Find the domain and range of f. All right, in order to graph this, yes, you could just go to your calculator, but what I would like for you to be able to do is know how to graph it if you don't have a calculator. So make a table of values and just pick some points. So it's good to pick points on both the left and right side of 0. So let's just choose some x values. Remember, x is our independent variable, so we can choose anything we want. So let's choose -2, -1, 0, 1, and 2. Now you can choose 100 if you want, but I'm trying to choose smaller numbers so it'll show up on my 10 by 10 graph paper here. All right, so these are good numbers to choose most of the time. So if I put -2 in here, I can say that 2 to the -2 is going to be moved to the bottom. So it's going to be 4 over 2 squared. 2 squared is 4. 4 divided by 4 is 1. All right, so you can write this down if you need to. I'm going to go through this kind of quickly. So 2 to the -1 is going to move to the bottom. So 4 over 2. 4 divided by 2 is 2. All right, anything to the 0 power is 1. 1 times 4 is 4. And then plug in 1. 2 to the first power is 2. 2 times 4 is 8. Well, let me rewrite that 8. Sorry about that. Let's see. 8. And then 2. Let's substitute 2. 2 squared is 4. 4 times 4 is 16. Remember, always do order of operations so that you can get the correct answer. All right, once you have your ordered pairs, now you need to graph the ordered pairs. So -2, 1. So -2, 1. -1, 2. 0, 4. And you'll see that 4 is your y-intercept. A is going to be your y-intercept always. So 1, 8. And then 2, 16 is going to be off the graph. But we can see that it's going to curve here and go up. This is exponential growth because your B, 2 is greater than 1, so it's a growth factor. I'm probably not going to do this justice, but I'm going to try here. So you're going to have an exponential growth somewhere in that vicinity. Trying to make it better. I think I'm just making it worse. All right. Not real good with using my screen to write on. All right, let's look at B part. It says negative times 1/2 to the x power. All right, so we know that the A is going to be -1 and my B is 1/2. That's a decay factor because B is between 0 and 1. And my y-intercept should be at -1. But again, let's look at the table of values. Again, I can choose any values I want. I'm going to choose -2, -1, 0, 1, and 2. All right, so if I plug in -2, okay, so that means my 1/2 is going to the bottom. So 1/2 squared would be 1/4. The reciprocal, that would be -4. All right, take -1, plug it in. Again, 1/2 goes to the bottom. It becomes -1 over 1/2. Do the reciprocal. I'm going to get -2. 0, anything to the 0 power is 1, so that becomes -1. Take 1 and substitute it in. That's just going to be -1/2. take 2 and substitute that in. 1/2 squared would be 1/4 times -1 is -1/4. All right, so again, we can graph these points. So I'm going to have -2, -4, -1, -2, 0, -1, 1 and -1/2, 2 and -1/4. And you can see that this one is going to be approaching 0 here. So those numbers are going to get closer to 0. Now, a good thing to do would be to graph these so that you can see them on your calculator, what they actually look like. So let's clear out the last graphs we had. So f of x is the same as y, so y equals 4 times 2 raised to the x power. Hit graph. You can see that this graph is going to be very similar to this one, except a little neater. All right, so go ahead and graph the next one. All right, so negative times 1/2 raised to the x power. Hit graph. And you can see how that graph comes up and turns and approaches 0 right there. All right, now it said to find the domain and range. All right, so for A part, the domain, you can see the x is going left and right forever, so your domain is all real numbers. So you can do -infinity to infinity, and your range is everything above the x-axis, so that would be all y values greater than 0. All right, for this one over here, you can see again it's going left and right forever. Let's go ahead and put the domain up here. Negative to positive infinity, same thing as all real numbers. All right, your range this time is below the x-axis, so it's going to be all y's less than 0. So that's your domain and range for A and B, example 3. All right, example 4, graph y equals 4 times 2 raised to the x minus 3 plus 2. Identify the asymptote, find the domain and range. All right, so you can see that this is just a transformation. Remember, h and k is your transformation, or that's your horizontal and vertical shift. H moves you horizontally, k moves you vertically, up or down, and this one moves you opposite the direction you think. So it's opposite h. All right, if you look at this graph, you'll see y equals 4, 2 to the x power. So if you remember, example 3, that's what we just did, 4 times 2 to the x power. So this is just a transformation of that same function. So if we go back here and we say 0, 4, 1, 8, let's take 2 of the points that we found. So if we take 0, 4, I'm going to put a point right here, and a point right here. And I know that that is from my parent function, y equals 4 times 2 to the x power. Now, if I want to graph this transformation, I can do that by just using the horizontal and vertical movements. So I know that I can translate the graph 3 units to the right. So this is going to move it 3 units to the right, and this is going to move it 2 units up. So let me change colors here. So if I go 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. I can easily sketch that graph because I already know what the parent function is. So again, I apologize before I do this, but I'm going to try to sketch this graph here. All right, so not as bad as it could be. Sometimes I feel like when I'm writing on here, I'm writing like I was in kindergarten, but that's just how it is. All right, now I shifted this one up 2. So now instead of approaching 0, it's going to approach this line right here. So I'm going to come down. It's going to be the same graph, but remember, I did shift it right 3 and up 2. So it means every point went right 3 and up 2. So again, it's easier. It's probably going to look a lot nicer if we look at this on the calculator. So say y equals, all right, 4 times 2 to the x power. That's going to be my blue line. That's my parent function. I'm also going to graph 4 times 2 raised to the x minus 3. And then bring this down and do plus 2. All right, so 4 times 2 raised to the x minus 3 plus 2. So this is going to be my transformation. So let's see if this will graph it. Blue, parent function. Red is my transformation. So you can see that the blue line approaches 0 here. And the red line, it hovers above this asymptote. So here, asymptote would be y equals 2 in this case. Y equals 2. Everything's going to be above that for this graph here. So for the domain and range, you can see that the domain, both the parent function and the transformation, so the graph of y equals 4 times 2 to the x minus 3 power plus 2 goes in both directions forever. So my domain is still negative to positive infinity. And my range, now everything is above 2. So since this moved up 2, now everything will be y greater than or equal to 2, where for the parent functions it was y greater or less than 0. All right, explain why the graph of an exponential function is not a line. All right, so remember, a line, your rate of change has to be constant. The graph of an exponential function, it is not a constant change. So that, therefore, the graph of an exponential function will never be a straight line.